In this video, we will be covering the bisection method, which is used to solve nonlinear equations numerically. So first we will consider the linear equations. Let's say these two linear equations. Consider these two equations. So x1 and x2 are independent variable here. So the power of these independent variables are equal to 1, so that the equations are linear equations. Okay. Now if you consider these same linear equations in matrix form, it will look like this. You are having this coefficient matrix and independent variable matrix and the constant matrix. Okay. So now you represent the equation in matrix form, and directly you can solve these matrices to find out what is the solution of these equations. It is the simplest way for linear equations, but this is not possible in case of nonlinear equations, where you are having your independent variable power which is greater than or less than, which is not equal to 1. Then you will be having nonlinear equation. For example, in this case you will be having your independent variables power equal to 2, so it becomes a nonlinear equation. So the power should not be equal to 1. And in other ways, you will be having in your equations, you will be having trigonometric function. In that case also the equation becomes nonlinear. Or if you are having a product term in your equation, like two independent variables are having this kind of products, then also this becomes nonlinear equation. So in these cases, we need to find an alternative method to solve these equations numerically. So we cannot use the matrix method for these kind of equations where you are having some kind of nonlinearity. Now in this lecture, we will be covering equations like f of x equal to 0, and we are focused on a single independent variable equation. So we will be having only one independent variable in our equations. And if you are having two equations, two independent variables and two equations like this, you can easily solve this kind of equation also, because first you find out what is the value of x2 from this equation, first equation. So it will be in terms of x1, and then substitute that in the second equation and find out what is the value of x1 and x2. But we will be covering only for the equation which is having only one independent variable in this lecture. So taking it in graphical method, this function in graphical way, we can have a nonlinear function like this, for example, where you will be having different value of f of x corresponds to different x values, and you will be having your 0 point, that is your f of x becomes 0 at this point. That is the solution of your equation, where you will be having the value of f of x equal to 0. The corresponding x is your solution. So we will be having different values of f of x in this regime, okay, for different x values. Now in this bisection approach, we have to choose one interval within which there is a 0. For example, in this case, we have to consider an interval from this point which contains this 0. So we can explain it here. If you consider this graph, this is the same graph, but let's consider this point, that is the positive value of f of x, and another point here where we will be having a negative value of f of x. So first we have to consider two x values correspondingly for you need f of x becomes positive and negative. So we need f of x equal to positive and f of x equal to negative, two values, and correspondingly we will choose two limits. Okay. So in this case, we will be having limit a and b in such a way that your f of x become positive in one case and negative in the other case, and in between that these two points, we will be having f of x equal to 0. Okay, that is the first condition. And then that value we have to reduce that interval. So for that we have to find out what is the average of these 2 points. In this case we have represented it by using a and b, so we have to take a plus b by 2. Okay, so then that is actually we are finding out what is the midpoint of these 2 points, and that is a plus b by 2, and we have to find out what is the function value corresponding to that midpoint. So if this function value, that is the f of x m, that is corresponding to the mid value, if it is positive, then we have to replace this a point with the corresponding midpoint. If it is negative, that is f of x m, where x m is your midpoint. If f of x m is negative, then you have to replace your b value with the x m. Okay, then you repeat this process until you have this condition, that is the absolute value of f of x is less than tolerance value. If this tolerance is if you are having 0.0001, then you check in each time, you check what is f of x m, which is less than or whether it is less than 0.0001. So we take this tolerance as 0.0001. So when this f of x m is less than 0.001, we have to terminate the process. Okay, so which means that f of x is almost equal to 0, and corresponding value of x m will be your solution. Otherwise, you can also take this condition, that is absolute value of b minus a is less than tolerance, that is your difference of these endpoints, that is b minus a. If it is very less than 0.0001, then also you can terminate the process, and the corresponding value of x of m will be your final solution. That is your solution to this equation. You will understand more in when we are doing this the example. Okay. So that's about this. We will be having a pseudocode for this method. So first we have to consider these intervals a and b. Then you have to find out f of a into f of b. So we have to check whether this f of a and f of b is less than 0. Then only we can have the both positive and negative values of the function. Suppose if you are having f of a is negative, then f of a into f of b becomes negative, or if f of b is negative, also f of a into f of b becomes negative. So in if this condition is valid, then we are having the function value which is having positive and negative at these endpoints. So we can choose a and b as your interval, because it will give you positive and negative values for your functions. Now you have to find out what is the midpoint, or you have to bisect the interval, that is x m equal to a plus b by 2, and find out what is the value of function at x m. You check whether f of x m is negative or positive, and the condition is like this. Okay, if f of x m star f of a is less than 0, then set b of b equal to x m, because when it becomes negative, you have to replace your b, that is negative boundary, with the new value x m. Else set a equal to x m, that is if f of x m into star f of a is less than which is not less than 0, which means that it is positive, then f of x m will be positive, and x m has to be replaced with a, because a was your initial positive. Then you have to break this operation by giving this condition, and when your f of x m is very which is less than 0.001, you have to break this. So we will continue in the next class. The